Hey everyone, welcome back. Today we're doing a little bit of a different kind of electronics build. My buddy Mike runs a Rocketry club for a local high school, and he asked me for some help putting together an Eggtimer Apogee kit. This is a DIY rocket altimeter and deployment controller. It pops your chute at the right apogee and even tells you the altitude your rocket reached after flight. Since it comes as a kit, we'll be soldering it up step by step and making sure it's ready to fly. Let's get started. First thing we're going to do is we're going to lay out all the parts. This kit includes a main processor, an Optoisolator, a transistor diode, resistors, capacitors, a buzzer, battery connections. Basically, the parts list that they give you, what you want to do is you want to lay out your parts and you want to double check that you have all the parts that are necessary for your kit. Accidents happen, things get left out. You don't want to be 3/4 of the way building your project and you realize you're missing something. So it looks like we have everything we need, so we're ready to get started. Okay, so we've moved over to the microscope and we're going to begin assembly with this screw nut. It's basically the switch that acts as the power control, the main power control for the entire board. When you tighten the screw, it completes the connection between this side on the back side of the board and this connection right here on the front side of the board. You're going to need a lot of heat to make the connection between this nut and the board, so you might want to use a larger iron. I'm going to use the same iron I have, but I did turn the temperature way up to about 800 degrees just to make sure I get good flow, and it's going to take a little bit to heat this up, get everything connect properly. So first thing we're going to do is we're going to tin this area here, get a nice decent solder connection, and then we might even try to tin the nut itself a little bit, but we'll see how that goes. So we're able to tin the connection here and also sort of tin the nut itself. Now we need to let it cool down because we're going to use the screw for the alignment, make sure everything's seated properly, and then solder into place. Okay, now that we've got the nut in place, I went ahead and pulled the screw out just to give us a little more space to operate in here. And we're going to move on to these ICs, and they get installed right here. Now you'll notice on the board, this little square indication here and here indicates the number 1 pin for each one, and then that's indicated by this dot or this dimple on each one of your boards. So make sure that this dot right here goes into this hole right here. We're just going to take it out and we're going to set it into the board. Kind of have to sort of, you know, get the pins lined up, and they bend over time, so just a little bit of flex there helps you get everything lined up. You can get everything lined up, and then you want to make sure it sits nice and flush, just like that. You get that right there, and then we'll end up soldering those pins on that side. I'm going to go ahead and put the other one in as well, right next to it. Same process, just like that. Then we can flip it over, making sure, like, I'll actually let it rest on those chips, make sure they sit nice and flush. All right, and then we can inspect our joints, make sure there's no old solder joints, make sure everything's nice, good, shiny solder points. So the next thing I want to do is probably the most difficult part of this build. It's a small surface mount capacitor that goes right here between these 2 points. I'm going to get the capacitor out. I'm going to tin these 2 points and then attach one side at a time to make sure that it adheres in place really well. The next part we're going to move on, once your surface mount capacitor is in place, we're going to move on to this diode. This diode is a one-way component. If you look here, it goes between this point here and this point here. This right here is telling you the positive end of the diode, which is also marked by this silver ring here. So you want this on this side here and this over here. I'm going to take some pliers and bend the legs down so that they can sit into the board properly. These capacitors, one is going to go right here. They're 1 microfarad capacitors. One's going to go here and the other is going to go down here. Same process as with the diode. These aren't polarized, so you can just slide them in. The next thing we're going to move on to are these 4.7 k ohm resistors. There's 1, 2, 3 here, and then this one up here. These are non-polarized. They can go in either way, but you can tell, in your kit, you should have 4 of them on tape like this. But you can also see it's gold, red, purple, yellow is the resistor code for resistance. Next is the 1 k ohm resistors. You can see they're gold, red, black, and brown, and they will go into these 2 spaces right here. This Darlington transistor is going to be the next component to get installed. It goes right here. It actually faces sort of the rest of the components on the board, just like that. Now the battery connector, this little JST header, sits right in here, and the side with the keyway on it, this little slot right here, is oriented here. To get this seated nice and flush, you want to be sure you don't hold the heat on these pins too long because you don't want to melt this plastic. So what I like to do is just get it in there, tack one side, let it cool, then go to the other side. You also want to make sure that you don't bridge the connections at all. It looks like we're good. These two pins are for a serial header, so you can update the firmware. You can reflash these chips in the future if new options become available or, you know, an update comes out for it. There is a long side to the pin and a short side. The short side is what goes into the board, and the long side sticks up here for attaching your data cable. Same with the battery connector. You don't want to hold the heat on here too long because you don't want to melt this plastic. The last part that we need to solder on is our speaker. It goes here. The speaker itself is marked. One of the legs is marked positive. You want to make sure that that's aligned properly. And once again, make sure it's flush and solder it into place. Once we have all of our components installed, we want to make a good inspection of all our solder joints and make sure that none of them are cold or cracked or breaking in any way. And all these look good. And that's it. We just finished building the Eggtimer Apogee from start to finish. This little board's now ready to power up, deploy a parachute, and tell you the altitude your rocket reached after flight. Big thanks to my buddy Mike and his high school rocketry club for letting me help out with this build. I think the students are really going to enjoy flying with it. We'll be doing a future video showing this on an actual launch, so make sure you don't miss that. If you found this helpful, hit that like button and subscribe for more DIY electronics. Drop a comment if you've ever built one of these kits or plan to in the future. Thanks for watching.